Everyone knows in 2025, NVIDIA is the king of AI resources, AI computing, and the best GPUs for all your AI needs. Take, for example, this 5080 right here. Expensive, top of the line, and great at what it does. But let's be real. Do you really need that to have an AI experience? I don't think so. This is the NVIDIA Shield TV from 2017 with a Tegra X1 and 256 CUDA cores. By the way, the 5090 is almost 85 times that, and 3 GB of shared memory and a whopping 16 GB of storage on the base model. I was determined to prove you don't need the latest flagship to run AI models. That being said, let's go engineer some stuff. The first thing we're going to have to cover in our road to getting AI models running on the NVIDIA Shield TV is storage. Like I said in the previous segment, 16 GB just isn't going to get done for anything that we need. So we're going to have to expand that storage by using removable storage like this PNY 128GB USB 3.0 drive that I got out of a 6-pack for Amazon for about 20 bucks. Now, if you have an SSD lying around external, you can plug that in and that'll format much quicker and get better performance. But for what we need to do, this guy right here will be just fine. So on our Shield TV now, we're going to go over to settings. Then we want to go under device preferences. And then once we're in there, we want to go to storage. And right now we can see we have removable storage and it's detecting our USB, which is exactly what we want to see, but we're going to want to turn this into internal storage to be shared by apps and media. So if we go over to our USB drive here, we need to go to erase and format as device storage. This drive appears slow. This is because it's not an SSD, and even on some SSDs, you'll still get this message. Don't worry about this. We can ignore it and still format the drive. Yes, it'll wipe everything out and we want to use this. Don't worry about that error message right there. You may see that is just because it's reinitializing the drive. So now it's going to sit here and it's going to format this USB drive. For my USB drive, it took a whopping 45 minutes and I had to reboot the system. If you have an SSD, it'll probably be faster than that, but don't worry if it's slow, it will format it correctly. Now that our Shield TV is rebooted, going back into storage settings, we can see our USB drive is being used for internal storage for apps, media, etc. I recommend migrating any data to the USB drive using that option as well. Storage that we have, and yep, we can see we have plenty of storage with the formatted capacity of the drive being about 122 gigabytes and only 3% used, so plenty of space for our AI models. One of the stars of the show to make this possible is Termux. Combines not only a terminal emulator, but also a package manager, and that package manager will allow us to use something called proot, which is like chroot, which will allow us to run Linux distributions on our Shield, full-fledged Linux distros that is, without needing to root the device. So I'm downloading the APK from F-Droid versus from the Play Store because the F-Droid version has many security fixes and bug fixes that we're going to want to pick up, which is important. And then we can just take that APK file and I'm going to show you how I'm going to transfer it to the Shield. There's a ton of ways to transfer files to the Shield TV like any Android device, whether that be ADB, a good old USB drive, cloud storage, you name it. But the way I like to do it, especially for a device like this, is FTP, File Transfer Protocol. So I like to use FTP server for Android TV to make that happen. Easy to start up, as we can see, and that'll get our APK transferred in no time. So with our Termux APK file transferred to the Shield, we'll go back into our File Explorer app and then head over to the Downloads directory. Let's select our APK and then select Install, and our installer will begin. It's important to note you will need to enable install from unknown sources, otherwise you'll get an error. So for security purposes, turn that on and then turn that right off. Once it's finished installing, we can select Open and it'll take us right into Termux. Since it's our first run, it will install the needed packages for basic usage to bootstrap everything. Once that's done, it should display the welcome screen of Welcome to Termux. And now we can start installing the necessary packages for Ollama and the other AI stuff that we will need. To actually get our Linux distribution installed, there are a couple of packages we're going to need. So the first one being proot. So to install that, we will run package install proot. Second one will be proot distro for handling distro operations, installed with package install proot distro. With proot distro installed, running proot distro list shows a large list of distros we could install, which is honestly pretty cool considering this is an Android device. I'll roll with Ubuntu. You could pick something else, but no promises that will work if you pick something else. Proot distro install Ubuntu will start our Ubuntu installation, which is case sensitive. As you can see, I did not realize that the first time. Proot distro login will take us right into a shell in Ubuntu Ubuntu, and yes, cat Etsy OS release shows we are running Ubuntu 25.10 Questing Quokka. To get Ollama packages installed, we will use the helper script they provide through curl with the output pipe to sh, which will execute the script once it finishes downloading. Once the install is complete, we're given a few warnings. Don't worry about either of them. The first one just means with no systemd, we're going to have to run the Ollama server manually. And the second warning I actually find pretty funny and kind of ironic considering this is an NVIDIA device, but all it means is that no PCIe GPU is connected, so it'll run through the CPU only, which in our case is actually a combined CPU-GPU processor. For running our AI model, I tried to pick a variety of prompt topics, whether that be programming, history, culture, geography, and a few other things there so we get a full valuation of how the model works. Later on, I'll discuss more of the whys of why I chose this model, and we get into performance and benchmarks, but for now, let's get right into the action and get this running. The easiest way to run our Ollama server manually is going to be with two terminal windows, where we'll run our server on the left and issue commands on the right. And to accomplish that, I'm going to be using Termux, not to be confused with Termux, which we had just installed. This is a popular terminal multiplexer that will allow us to divide the windows into 1 and 2 windows or more, but we just need 2 for our case. And while I didn't record myself installing that package, I'll put up the commands for that right now on the screen. Alright, so with my two Ubuntu terminal windows open side by side, in the left-hand side window running Ollama start, we'll start up our server and we will see a bunch of info logs flash by. The most interesting ones to us anyway is that it has correctly picked up the 3 gigabytes of shared memory, but only approximately 720 of that is available for us because some of it still needs to be allocated to the underlying Android OS. And because of that 3 gigabyte memory, we're in low VRAM mode, well short of the 20 gigabyte we would need to not be in that mode, which you would need a dedicated GPU for, like an RTX 5090 or something even greater than that. To download and run our model, we will do Ollama run small m2 360m. This is the 360 million parameter version of this model that is specifically designed for devices with limited computing resource, just like our Shield is. And once it completes, it will drop us into the prompt shell. We can start sending it messages. Now for these prompts, I will speed up the time it takes to generate a response because it does take a while on some of these to generate that response. So if you're curious about the real world usage stats and times, you can just look on the left-hand side and it'll tell you what the actual time for the prompt to respond was. So the first prompt I threw at it was a classic programming exercise, hello world in Python. And while the code itself is fine, it did hallucinate, including a dunder name and dunder main section, which was not actually the case. And definitely not the best wording on saying compile into executable. I would have said run your code in the Python interpreter. History question time, and I asked it for the first 10 presidents of the United States. Started off pretty good until it completely skipped 23 years worth of presidents, then it went back and placed them in the wrong weird order, and it repeated William Henry Harrison twice. So not great if you're trying to use this for your homework or some other historical learnings. And then on to geography. When asked for a list of all 50 US states in order alphabetically, it did a good job for the first 36 states until it left off Oregon. Sorry to any Oregonians out there. Then a few more down, it left off South Dakota, but the rest were fine, which is funny to me as it said there were no states with the letter U, but clearly named Utah in the correct alphabetical order. Math-wise, I wanted to ask it something LLMs are notoriously known to struggle for, which is lists of counting and anything related to prime numbers, so I asked it for the prime numbers up to 100, and to my surprise, it nailed this actually. At the suggestion of my wife, I asked it if it knew the lyrics to My Heart Will Go On by Celine Dion for a culture question, and wow did it struggle with this, first naming a random song from the 1960s, and when specifying the song from Titanic, gave us a song by Gershwin instead. Then being even more specific and saying My Heart Will Go On by Celine Dion gave us a different song by her instead. I guess this model's heart will not go on. Being from Boston, I wanted to ask it a more nuanced geography question about the New England states and their capital cities. I actually got them right for the first 6 entries until it started repeating itself and hallucinating New York and New Jersey and several much further cities which are not part of the New England states in this region at all. Now, as promised, System Performs was something I was really curious about. So I opened a third terminal window right below the prompt window and ran the top command to see the most resource-intensive processes. And I chose a prompt that would really stress resources for this. What are the parts of speech of the English language? Because I knew this would take a while for it to generate everything. It may seem wicked surprising to see 350% CPU utilization, but for a multi-core system, we have 400% utilization available to us, so around 87.5 of our shared CPU-GPU is being used for our LLM, and the rest of the Android host OS, so this is actually not too bad to see. And 30.3% of memory usage makes sense since the rest of the memory is being taken by Android itself, and only a limited amount can go to our LLM and our Linux machine that we're running. For the last bit here, I want to briefly go over why I chose this model and why it works well for our needs on the Shield. And I just want to say shout out to Hugging Face because it really does have so much great info on the models, training data, pros, cons, and all kinds of other charts and info that you can need to make a good decision about what model would fit your situation, what it's best suited for. So for small LM2 with 360 million parameters, which was mainly trained on the FineWeb EDU, DCLM, and the stack, which is full of code and programming examples for data sets. The overview article here I found for small LM2, I'll put all this in the description, don't worry. It has great details on its benchmark scores comparing it to the original small M model as well as the larger Qwen 2.5 500 million parameter model. And honestly, these benchmarks are pretty impressive considering the model's small footprint, especially against Qwen's 2.5 model, which has 180 million more parameters. Now, a huge weakness, though, of the small LM2 is the poor performance in GSM 8K, which is a collection of about 8,000 grade school math word problems. We didn't get to fully test that, but looking at those benchmarks, it would not have fared well in that area. And another big limitation is this model is mainly trained in the English language, so if English is not your native language and you're looking for translation tasks or just aren't a native English speaker, this is not going to be the model for that, unfortunately. I could only find an article for the original small M model for memory footprint, but looking at the chart, using about 724 megs of memory in the BF16 mode we are in is absolutely perfect for the 700 to 800 megabytes we had to work with on the Shield. As we've shown today, you truly don't need the latest and greatest GPU hardware to run AI models. In fact, there's something really cool about getting as much power and performance as you can out of old hardware and repurposing it to do something awesome and modern. Also, thank you so much for 140 subscribers. I love reading the comments. I love seeing that these videos have helped people, and it just really means the world to me to see people watching and interacting with these and getting something out of them. So thank you so much for that. In fact, please don't forget to like and subscribe. I have a bunch of new video ideas coming out in 2026, and I don't want any of you to miss any of them. And as always, I'm Sam, the engineering man, and I'll catch you all in the next one.